Role of analogy in architecture design education. Abstract analogy is a powerful approach for problem solving, learning, or discovery that employs a practical method to achieve the immediate goals. In design, where designers are constantly exposed to stimuli, analogies are considered to be particularly helpful. However, few researchers have given enough attention to analogy in design contexts. Therefore, this study deals with the use of these tools by investigating the effect that students have on them through analogical learning and thereby proposes a framework to enhance the process of designing among students with the use of analogy. The aim of this research is to develop a framework of analogy in Design Studio for the purpose of inducing analogical learning among the students of Bachelors of Architecture, second year. The framework also incorporates analogical reasoning and thinking through analogical learning. The research will also evaluate the comparison between the results of the pre-test, i.e. before introducing the analogical learning, with that of post-test, which is after presenting various approaches of designing to examine the effect of analogy used on the design solutions of the students in architecture design studios. Index terms: analogy, analogical thinking, analogical reasoning, design process. Introduction. Analogical thinking involves the use of prior source information that can aid in the solving of a current target problem. Reasoning by analogy is considered to be at the center of cognitive processes, in particular those involving creative problem solving, Keith J. Holloke, 1995. Whereas research on analogical thinking is prolific, little work has been done on analogy in the visual domain. In design problem solving, visual analogies are frequently used in design, in part due to the large variety of visual displays that aid students when searching for creative design solutions. Since the design process is viewed as an explorative activity characterized by visual thinking, Goldschmidt, 2003, the use of visual displays by means of analogy is considered a potent strategy for creative problem solving. Few investigations dealt with different aspects of the use of analogy and visual displays in design problem solving. Some examples are Goldschmidt, 2003, and Goldschmidt H.C., 1999, who investigated visual analogy in design, and Kazakin, 2006, and Yilmaz, 2017, who studied the effect of visual displays on design performance. All these works acknowledged the critical role played by visual representations in creative problem solving. Despite the crucial function that is argued for visual reasoning in creative problem solving, few existing research seems to have paid considerable attention to visual analogizing in different design problem contexts, or under different levels of expertise. This research reports the results of design improvement as a result of the use of the framework in visual analogy and visual displays in ill-defined and well-defined problem solving. A major focus is set on the role played by design expertise and creative activity. Hernan Kazakin, 2007, characterized by visual thinking. Goldschmidt G., April 1994. The use of visual displays by means of analogy is seen as a powerful strategy for creative problem solving. Researchers like Goldschmidt G., April 1994, who investigated visual analogy in design, and Smolkov, September 2006, who studied the effect of analogy on design performance, acknowledged the importance of visual representations on creative problem solving. Goldschmidt G., April 1994, explained that establishing correspondences between sources and a design target can assist in a successful organization of the design into a coherent structural system. Creative cognition processes embracing the use of analogy are critical in the generation of new ideas. In this process, designers redefine the design problem from innovative viewpoints, Sean, 1983, and establish analogical associations with the design problem. Generalizing and transferring analogical principles from one domain to another. The design process goes through the flow of information along with ideas, but at different levels, and design is a set of ideas and events, and the architectural mind searches in memory to find elements and components that match the needs of the problem, and compensate for the lack of information through the various references. The designer can achieve a wide range of goals through the design idea, and different projects vary these objectives or change the value resulting from the achievement and hence show the levels of application of the architectural idea as follows. Sarah Armageda, June 2019. The classification of ideas may be difficult as the way of thinking and expressing it is clearly different from one person to another, but there is a link between each group of ideas that makes it a doctrine and direction analogy to it in its general framework and characteristics are driven to say that this idea follows him or not, and here the relationship of analogy to thinking of three levels, formal, functional, and structural, is evident at the level of architectural design. The types of architectural ideas may be classified as follows. The planning idea. This idea is reflected in the overall planning of the project as a whole to appear in the buildings and coordination of the relationship and bonding of the blocks, usually in multi-building projects or projects that require open areas with specific spaces, and this idea is a general idea mostly include type or more of the following ideas mentioned. Technical idea. This idea deals with the core of the design problem directly through its solution in a purely technical manner, and using the means of technology and innovations. It should be noted here that it cannot be said that this idea is a design idea unless it affects the design directly. The goal is to design a product that solves a problem, not a problem for any design, but it is ultimately dry and expansive, so it is also best to combine it with another kind of ideas to give it a soul. Sarah Armageda, June 2019. The philosophical concept. The philosophical approach is one of the most powerful intellectual schools and has the ability to convey general concepts. At the same time, it may lead to disdain of the idea, especially when the philosophy becomes a novel with several chapters. The strength of this type of ideas is reinforced by the multiplicity of ideas and their links with the project and its components. It is also necessary to mention here the need to move away from the surface in the translation of the idea and the search for the dimensional dimensions of its contents. Broadbent, 1973. Inspirational idea. Each line of the lines gives a different impression in the brain, and when combined together in a stereoscopic shape, a general suggestion is formed that translates into the brain in a certain way: happiness, hope, sadness, balance, disturbance, etc. It can be said here that this type of ideas is often used with another type, because it does not ensure the delivery of the side of inspiration in a uniform manner for all. Sarah Armageda, June 2019. The symbolic idea. It is very analogy to the idea of inspiration, but does not depend on the meaning inspired by the line and the interpreter of the brain receptor, but depends on the link of the shape of the project through some of the usual symbols, such as the food dish linked to the restaurant, or bank paper bank, and so on. In primary forms or lines should not reflect the basic form of the element but symbolize it. Impressionist idea. It is a very superficial idea and a lot of criticism, and it can be said that it does not require a high amount of knowledge and does not need to develop where a project-related element is captured and falls on the project's current form as it is. It is not clear here that this type of thinking has failed. Abstract idea. Here the designer to quote a specific element and be of a symbolic or inspirational nature, but not only contrary to the design, but enters the process of abstraction to finally get a new form, serves the distribution of blocks required according to the studies of the project, and the strength of this idea if the introduction, the philosophical aspect of the process of abstraction itself. Sarah Armageda, June 2019. Structural idea. The construction idea is often derived from the abstraction of a structure in nature, used to solve the problem of construction, but in a unique way. It can be argued that this idea is a branch of the abstract idea. Broadbent, October 1970. Analogy as visual stimuli and idea generation in design. A supporting analogy for idea generation in design education. The previous studies demonstrated that students are not always aware of the importance and utility of analogical reasoning in design. Therefore, its appropriation and implementation requires training. In this last part of the chapter, an intervention program would be approached, which ultimate goal is to help students progressively develop the abilities required to use analogy spontaneously. The way that an analogous examples are represented and perceived, i.e., handmade sketches, schemas, drawings, photographs, affect how knowledge is retrieved and applied to the problem at hand. K. Locke, 2008, J. Hay, 2008. The suggested educational approach includes a number of training phases that goes from basic cognitive operations such as analysis of design principles from examples, finding commonalities between different problems, and more complex problem-oriented tasks like experiencing problem situations that are similar to the problem at hand, e.g., Bransford, 1989, Beg. Problem-oriented training promotes spontaneous analogical transfer, memory-oriented training, 1991. The program includes the following stages. Identification of knowledge from within domain sources. This first stage of the training process consists in the analysis of basic design principles from visual displays belonging to the architectural field, like for example building schools, libraries, etc. In particular, students are exposed to a collection of architectural precedents, considered as authoritative examples by well-known architects from whom it is possible to learn a lesson. The aim of this stage is to identify and retrieve design ideas from within domain sources, and represent them graphically by means of sketches and diagrams. Sarah Armageda, June 2019. Mapping of knowledge from within domain sources. The second stage of the process deals with the identification and mapping of commonalities from visual stimuli belonging to a same knowledge category, e.g., different types of high-rise buildings. Students should identify and map common shared principles from available sources, and represent them graphically using schemas. It is expected that higher-order relations, structural similarities, will be established between some of the visual displays. In a following step, a similar task will be conducted where students need to identify and establish mappings between visual sources belonging to different typological groups, e.g., schools and libraries. The aim is to help students make high-level abstractions and establish structural mappings from close sources. De Jong, 1989. Use of within-domain and between-domain analogy in design problem solving. The third stage consists in a problem-oriented task concerned with the use of within-domain analogy in design problem solving. According to Ward, 1998, the construction and application of highly representative, and therefore easily accessible analogs is a most frequent activity in problem-solving activities. Sarah Armageda, June 2019. Therefore, in this phase of the process students will be exposed to a number of problems that are similar to the problem at hand, and will be instructed to use analogy to solve the problem. Previous studies, Kazakin, 2010, Goldschmidt H.C., 1999, Kennedy, 1990, showed that instructions to use analogy have a strong effect on analogical reasoning. One of the reasons is because instructions imply the existence of implicit or explicit goals that affect the whole analogical process. Keith J. Holloke, 1995. In a second step, students will be provided with a different problem and a panel containing within-domain and between-domain visual displays. It is expected that students will be able to apply the cognitive mechanisms with which they were trained previously, and will identify, map, and transfer ideas from the available visual analogs to the target problem. The use of various source domains is believed to aid in the production of successful analogies, and in the quality of the design ideas. Morrow, 2002. Conclusion. In the experiment of this study, the students learned about concept designing through a framework based on analogical learning to gradually develop their own concepts incorporating various approaches in their design. Their new knowledge helped the students to develop better design knowledge and vocabulary. This study confirms the feasibility of using analogical thinking in the teaching of architecture design to enhance analytical skills, improve presentation skills and graphic skills. Another aspect that deserves further attention is the role that analogy plays in design education. Analogical learning enables students to acquire skills and knowledge, while they develop their own design solutions and ideas. Alternatively to the traditional approach, analogy is proposed as an educational tool for the design studio. The use of visual analogy is recommended for intervention programs that aim to help students develop design knowledge, problem reasoning, and problem solving and their own design languages. Recommendations: breaking the studio class into smaller groups. Having smaller groups would give more time and attention to individual projects, allow more discussion, and help keep the students' attention. Better time management of the process. A better time management for the exercise would include limiting the time in which each student has to present their ideas and allowing the same amount of time for feedback to be spent of each individual project. This will keep students more focused and interested in the discussions. Students should be allowed to choose their own analogical examples. Students should be given freedom to choose their own analogous cases in order to avoid fixation to a specific solution. More encouragement of students in the discussion. Encouraging students to engage in the discussions while other students are presenting would help them learn and analyze from other students' design. Submission after the activity. The submissions should occur after the analogical learning to ensure that students get enough time to incorporate the suggestions in the design. A wider variety of jurors. A wider number of teachers to be involved in the discussions to offer students different viewpoints on the feedback they receive. Establish a written statement that describes the purpose of design problem to guide students and faculties to enhance their understanding of the problem. Acknowledgement. First of all, I would like to thank the Almighty God for providing His infinite blessings. We would like to thank our faculties A.R. Mohammed Saqib, A.R. Mohammed Amir Khan, A.R. Baljit Khurana for providing their guidance for completion of this dissertation. I would also like to thank to A.R. Sonia Chaudhry for her guidance on research design that proved helpful in this paper. Special thanks to my parents who always support me no matter what. Also, I would like to thank my friends, especially Aishwarya Sharma for the constant support and encouragement.